Okay everyone, in this video we will discuss question number 13 from Oxford for Mathematics AI HL book chapter review 10. Okay, about calculus. So the question is, consider the function defined by fx equals with x squared divided by 2x to the power of 3 minus 1, where x is not equals with the third root of half. Find the expression of f and x. It means we have to find the first derivative. For this, I would like to use the multiplication rule. If you want to use the division rule, that's totally fine, but I like to use the multiplication rule. In that case, we need to change this one into something else. So fx is equals with, change that, we have x squared times 2x to the power of 3 minus 1 time to the power of negative 1. Okay, so we move this denominator up. So we will have our u, in this case is x squared, and then u accent is derivative of this 2x, and then our v is equals with 2x to the power of 3 minus 1 to the power of negative 1, and then v accent is equals with, chain rule, negative 1 go from negative 1 times same content in the bracket, 2x to the power of 3 minus 1 to the power of negative 1 minus 1 negative 2 times the derivative of the content in the bracket. We will have derivative of 2x to the power of 3, we have 6x squared. The one is just gone. So tidy up a little bit. V accent is equals with negative 1 times 6x squared. We have negative 6x squared, 2x to the power of 3 minus 1 to the power of negative 2. So that is our u and our v calculation. So let's go back here. Okay, so we can finally calculate our f accent. X is equals with u accent v, oh wait, that u look like a v, sorry, u accent v plus u v accent, that's more like it. So it equals with the u accent is 2x times v is this one, 2x to the power of 3 minus 1, but the power of negative 1, we will write it like this, 2x to the power of 3 minus 1, okay, plus u, the u is x squared, times v accent is this one, negative 6x squared, divided by 2x to the power of 3, 2x to the power of 3 minus 1 to the power of to the power of 2. Yeah, we move it down, so it will become positive. Yeah, this is negative 2, but we move it down, become positive 2. So we can make this sign a little bit longer. Yes. Now, as you can see, we have similar denominator. We just need to multiply this to make it similar. So let's take this one. So just multiply this part with 2x to the power of 3 minus 1. Multiply this part also with 2x to the power of 3 minus 1. We do it because we want to make this one, the denominator of the left side, we have the same square. So we will end up with equals with, decline, same denominator. Now we have 2x to the power of 3 minus 1 square, and then we can calculate 2x times 2x to the power of 3, we will have 4x to the power of 4. 2x times negative 1, we will have negative 2x, and then and then x squared times negative 6x squared, we will have negative 6x to the power of 4. We can simplify it again, we will end up with same denominator, 2x to the power of 3 minus 1 square, we will have 4x to the power of 4 minus 6x to the power of 4. We will have negative 2x to the power of 4 minus 2x. This will be our f accent x. That's the answer for A. Yeah. Let's draw this, put it here. Okay, let's move on to B. We have to find the equation of the tangent. So we have to find the tangent equation to the curve at the point where x equals to 1. So we have to find the equation of the tangent when the x is equals to 1. So B, equation of the tangent is y equals with mx plus c. Yeah, we need to find the m first, the gradient when the x is equals to 1. We already got the gradient function, which is this one, f accent x. We just need to input the x is equals to 1. So let's input that one first. So we will have f accent 1 equals with negative 2x to the power of 4, negative 2, 1 to the power of 4 minus 2x, 2 times 1, divided by 2x to the power of 3 minus 1 square. So it means 2 times 1 to the power of 3 minus 1 square. So we will end up with, let's bring it down. So we will have m, I'll just write it as m here because this is the gradient, is equals with 2, 1 to the power of 4 is 1, so negative 2, 2 times negative 2 times 1 is negative 2, 2 times 1 to the power of 3 is 2 minus 1 is 1, so we have 2 minus 1 square. So the m is equals with 2, negative 2 minus 2, negative 4 divided by 1. So m is negative 4. So we got the gradient, yeah. Okay, we got the gradient. We need to find the c. To find the c, we need to find the point. We need to find at least one point. We already have one here. We have one. When the x is 1, we have to find what is the value of y, because the point is x and y. We got the x is 1, we need to find the y. The y, we can get it from here. Just input the 1 into this equation, the original one. Let's see what do we have. Yeah, so f1 is equals with 2. We need to find the y, yeah? X square over 2x to the power of 3 minus 1. So we will have x square, 1 square over 2x to the power of 3, 2 times 1 to the power of 3 minus 1. So it means f1, or in this case y. Remember the x is 1, yeah? The y is equals with 1 square is 1 over 2 times 1 to the power of 3 is 2 minus 1 is 1. So y is equals to 1. So we got a point. So the point is 1, 1. So this is the value of x, this is the value of y. We can just input this to our equation. Y equals with mx plus c. The y is 1. 1 equals with, we look for the c, yeah? 1 equals with mx. The m is negative 4 times x, s is 1, plus c. So c is equals with 1 plus 4. We move the 4 to the other side. So c is equals with 5. So finally, the equation. Sorry, I put it here. But let's change the color a little bit so we have something different. So the color, let's change that. Oh no, different one. So the equation of the tangent, is y equals with mx negative 4x plus 5. I think we can show this in the end later using GeoGebra, yeah, later, yeah. Okay, sorry. Yep, equation of tangent is y equals with negative 4x plus 5. Let's move on to C, equation C. We have to find the coordinates of the points on the curve where the gradient is 0. The gradient is 0. We have to look back over here. Let me cut this a little bit. Where is the sniping tools? This one. Let's cut it here. copy it down, bring it down, paste. Wait, can you bring it down? Yeah. Okay, you are there. Let's read again the question. Find the coordinates of the points on the curve where the gradient is 0. So where the gradient is 0, this is the function of the gradient. We have to find the x when the gradient is equals to 0. The gradient is equals to 0. If you look at it, it will be this one, the top part, this top part. If this top part is 0, whatever the value here, it's always be 0, because 0 divided by anything is 0 except 0, yeah? Except divided by 0, it will be undefined. But in this case, we can say the gradient will be 0, so the m will be 0 when negative 2x to the power of 4 minus 2x is equals to 0. Yeah, so we can just input this to equation. Let's calculate this, factorize this. Factorize negative 2x, we will end up with negative 2x to the power of 4 divided by negative 2x. We have x to the power of 3, that's 4, x to the power of 3, and then negative 2x divided by negative 2x, we have plus 1 equals to 0. So negative 2x equals to 0, x equals to 0, or x to the power of 3 plus 1 equals to 0. So x to the power of 3 equals with negative 1, x equals with negative 1. The third root of negative 1 is negative 1. Yeah, so we got the x. Let's go back up. What's the question? Find the coordinate of the point. So we have to find the coordinates of the points. So it's not only the x, yeah, we have to bring it back to the original equation. Wait a second, I will take the original equation down. Okay, find the coordinates of the points on the curve when the gradient is 0. We already got the x here, x is 0 and then x is negative 1. We just need to find the coordinates, yeah. When the x is equals to 0, the y will be y equals with input the 0 into this one. We will have 0 square divided by 2 times 0 to the power of 3 minus 1. So y equals with, let me make a line over here, y equals with 0 divided by anything over here, we don't care, it's 0. Okay, so we have 0 and 0. So this first point when the gradient is 0 is 0, 0. That's the first point. The second point, when the x is negative 1, when the x is equals with negative 1, we will have y equals with negative 1 square times 2 to the 2 times 1 to negative 1 to the power of 3 minus 1. So the y equals with negative 1 square is 1 divided by negative 1 to the power of 3 is negative 1 times 2, negative 2, negative 2 minus 1, negative 3. So the second point when the gradient is 0 is negative 1 comma negative 1 over 3. Okay, so this one should be the answer for the question C. Okay, for question D, let me take the question. Okay, for question D, we have to find out the range of values of x for which f(x) is an increasing function. What is the meaning of that? The meaning of increasing function, it means the gradient or the m should be more than 0. Okay, the gradient should be always more than 0. This is the gradient function that I took from the top part. This one. This is the gradient function from here. So the gradient function here, we have to make sure that the gradient is always more than 0 or always positive. If that's the case, this one, let's take a look at the function of the gradient itself. On the denominator here, we have something square. Yes, something square. something square, whatever the something is, it will always give us positive answer. Okay, so we only need to make sure that the top part is also positive, because if positive divided positive, it will give us positive gradient. So if that's the case, so let's just calculate negative 2x to the power of 4 minus 2x should be more than 0. Okay, that's the catch. Yeah, we just need to change this to find the factor, which is negative 2x to the power of 4 minus 2x. Make it into 0 first, factorize it. After we factorize it, just like this, we already factorized this. We got x equals to 0 and then x equals to negative 1. So x equals to 0 and x equals with negative 1. Okay, so we just need to find the draw this in the number line. Wait, it should be this one. Yeah. It's not full, yeah, because this is it doesn't contain the equal sign. So from negative 1 until 0, we need to test which value will give us the value of positive, which is more than 0. I think we already tested that once with this one. This one, when the f is equals to 1, this one, yeah. When the x is equals to 1, the gradient is negative 4. Yeah, when the x is equals to 1, the gradient is negative. It's from question B. It means this one is negative, this one is positive, this one is negative. It is negative, positive, negative. So if that's the case, we need something that positive, which is more than 0. So the value of x should be between negative 1 until 0, or we can write the value of x should be more than negative 1 but less than 0. Okay, I think that's it for the discussion. You can prove it yourself using GeoGebra, because this video is already very long. Thank you everyone. If you have any question or if I make a mistake, please let me know in the comment or email me at sinomaths@gmail.com. Thank you everyone. Have a good day.